talking about database management approaches, there's really 6 areas that we need to address and look at. The first one is, what is a non-volatile data warehouse? What does that mean? Second, we need to look at fact and dimension tables. What are these and how they relate to each other? When do you use OLAP? How do you use OLAP? What is data mining? And finally, what are some examples of data warehouse technologies? So what does it mean when a data warehouse is non-volatile? It simply means that once data is inserted, the data record is not changed or deleted. Updated information is stored as a new record. Records are connected. This gives us a life cycle of the records, and it also gives us an audit trail. For example, at the organization that I work at, Infinity LLC, we deal with health insurance claim information. An insurance claim can go through several iterations and updates throughout the adjudication process. Each of these iterations is stored as a separate claim record in the database. These records are shown as related by having a common identifier. This provides an audit trail of the state of the health insurance claim through its life cycle, and it's also a requirement for our ENAC certification. So what is a fact table in a data warehouse? A fact table is a repository where facts about the data object are stored. The details of these records are stored in the corresponding dimension tables. Fact tables contain that metric information about the record, data specific to the instance of the record, and foreign keys to the dimension tables where the details are stored. An example of this is the mutual agreements or contracts that each of our clients signs. In the data model for this, the fact table is the mutual agreement table. This stores the records with the metric information, such as the dates related to when that instance of the mutual agreement was created, and what are the foreign keys to the dimension tables that allow the system to build a specific mutual agreement for a particular client. These dimension tables include records for things such as fee schedules, contract text, enrollment codes, client types, fee items, and electronic signatures. This allows for a narrower, more vertical fact table with dimension tables that are more horizontal. OLAP stands for Online Analytical Processing. So when do you use OLAP? Using OLAP tools allow you to analyze complex data relations to help clients better support their business. With OLAP tools such as OLAP R and Python cubes, data can be organized and aggregated along the multiple dimensions of a data cube. In one recent example, a provider organization had questions regarding the insurance payer's rejection of specific dyads of services involving evaluation and skeletal manipulation services in the same encounter or the same office visit. By analyzing the encounter data along with the dimensions of time, combinations of services, providers, insurance payers, adjudication results, and even the states, we could determine if there is a pattern of the data that's more likely to result in a rejection of the insurance claim. So what can you do with OLAP? So there are typical actions that users can perform, and 3 of those actions are data rollup, where you aggregate the data across a specific access, combine the data dimensions, and compare the behaviors. You can also slice and dice the data, extract specific data and details, compare the data along the axis, or create smaller subsets of a data cube. Opposite of rollup, you have the data drill down, where you can break that aggregated data into smaller components, compare the underlying data, and focus on that actionable information. So one of the key things that you can do in a data warehouse is data mining. So what is data mining? Data mining is analyzing data to discern patterns and extract value from data for better decision making. Some of the approaches you can use to do this are prediction, classification, and outlier analysis. In our organization, we've created a prediction model That's our red flag analysis. In this analysis, we look at our client's claims history to determine if their usage of specific medical procedure code combinations compared to specific diagnoses for the patient determine if the client is overusing certain codes and are at risk of an audit by CMS, the Center for Medicare and Medicaid Studies. By comparing the behavior of clients in the period leading up to an audit, we can create a pattern of risky behavior that we can then use to predict if a client is at risk of an audit. In a classification model, we use classification and clustering analysis to create a set of models of the types of clients who use our services. This allows us to streamline the enrollment process, creates a multi-track enrollment system rather than the linear and time-intensive process we'd used previously. For example, as we collect information about the client, we can identify which classification a client falls into and begin payer enrollments earlier in the process, rather than waiting for that step in the legacy linear process. This has reduced the average enrollment process from 90 days to around 30 to 40 days. Our data science team also works extensively with independent physician associations to analyze the activity of their members. By managing their members within a set of guidelines, they can negotiate better rates from the insurance payers for their members. We analyze the number of services per visit and visits per patient, and with this information we can identify outlier members whose utilization is more than 2 standard deviations outside the median. We can also identify members who are at risk of becoming outliers so the IPA can take corrective action. The Brown Box podcast illustrates how systems and people can interact with the data warehouse, but it also illustrates that legacy data warehouse technology lacked the ability to learn from errors. Current technology incorporates artificial intelligence and machine learning and combines hardware and software. It also integrates with third-party tools like Tableau and Power BI. Some examples include Redshift, which is Amazon's current data warehouse technology. Redshift combines cloud-based managed data warehouse services and provides APIs, SDKs, and CL tools to allow users to leverage the power of Amazon's data warehouse. Redshift also fully integrates with third-party data analysis tools such as Tableau and Power BI. One example that I've worked with is Microsoft's Azure Synapse Analytics, which integrates with the Azure Data Factory, Power BI, which is Microsoft's business intelligence tools, and other third-party analytics tools. Another third-party tool is Snowflake, which is an overlay that allows us to integrate data across disparate databases, such as our Azure SQL Elastic Pool, our Azure Managed Data Warehouse, and our in-house MS SQL Always-On Availability Group. As we've seen in the previous slides, data warehouse technologies are constantly evolving and improving. As recent as 15 years ago, only large organizations such as Walmart could afford the cost to house large amounts of data and the expertise to make use of that information. Today, the software and hardware has become ubiquitous, and even small organizations like mine can leverage the power of large data sets with cloud-based data warehouses from Amazon, Google, and Microsoft.